Today we're going to be looking at section 9.6, factoring trinomials in the form ax squared plus bx plus c. Our steps to follow are going to be, first we have to consider what the factored sign's result must be. And what I've done to do this is I put together a little bit of a flow chart which hopefully will help us see this. And our flow chart basically is going to give us what we're going to need to do when we're looking at a trinomial. And so here we have a trinomial in this form, ax squared plus bx plus c. So what we're going to do is we're going to look at the sign of the last term. And when I say the last term, I'm talking about this term right here. And if that c value is positive or negative, then we're going to have to consider two different possibilities. If it's positive, then we're going to look at the second sign here. If that sign is positive, then we're going to end up with two positive numbers. If this second sign, this plus b, is negative, then we're going to end up with two negative numbers. Now, if the value of c is negative, then we're going to have a plus and a minus, and the order doesn't matter. So just as a general flow chart, that's a very good flow chart to have to consider what our signs are. So let's look at our first problem. 3x squared plus 17x plus 10. As we're looking at this first problem, we're going to have to consider, okay, first of all, what are our signs? Well, the second one has the sign of a positive 10, and so our signs must be positive and positive. That's the first step in our process. Our second step is to look at our different factors. We have number 3, and we have a number 10. As we consider these two numbers, the only possibility for 3 is 1 and 3, and there's two possibilities for 10, 1 and 10, and 2 and 5. Well, because 1 and 3 are the only possibilities, that means this first part has got to be 3x, and the second part has got to be 1x. The order really doesn't matter. We'll deal with that in a sec. Next, let's look at what the other two numbers have to be. It could be either 1 and 10 or 2 and 5. Let's always try the middle numbers first because they're closer together. So I'm going to try the numbers 2 and 5, and I'll put the 5 here and the 2 here. Well, let's try outside and inside as our two possibilities. Outside, 3 times 2x is 6x. Inside, 5 times 1x is 5x, and that gives us a total of 11x. As you can see, that doesn't equal the 17 that we have. So what we're going to need to do is we're going to need to take out those 2 and 3, and we're going to have to consider what else we might try. Well, instead of saying 2 and 5, let's now try 5 and 2 in the reverse order. So let's put the 2 first and the 5 second. Now our outside is 15x and our inside is 2x. That gives us 17x. So my final answer then will be 3x plus 2 times x plus 5. We really don't need to write the 1 in front. Let's look at our next one. Here we have 8y squared minus 10y minus 3. We consider our signs. The sign of the back number, as you see, is a minus 3. That means the signs of our problem need to be a plus and a minus. All right, let's do our factors. We have the number 8 and we have the number 3. Our factors of 8, 1 and 8, 2 and 4, and our factors of 3 are 1 and 3. Well, since 1 and 3 are the only possibilities, let's put those in, 1 and 3. Without a doubt, that has to be true. I always like once again to try the numbers that are closest together, so I'm going to try 2 and 4. So 2y and 4y, and let's try the outer and the inner. Outer, negative 6y, and I want to emphasize the negative number is important to remember here. And then we have a positive 4y. That gets us negative 2y. That didn't work. Once again, it's not even a positive 2y, and so I know that 2, 4 in that order doesn't work. So instead, let's try and look at reversing those two numbers, and instead of using 2, 4, let's use 4, 2. Now our outside and our inside gives us negative 12y and positive 2y, and that summarizes to negative 10y, which means we found our answer. And our final answer will be 4y plus 1, 2y minus 3. And there we have it. So this one we had opposite signs, which led us to opposite signs in our answer. Moving on to number 3. Can you think about what your signs are going to be? Well, if you're not sure, we want to look back to our flow chart and we say, okay, are the signs the same or are the signs different? Well, in our case, these signs are the same because we have a plus at the end, and so then we look to the middle sign to see which one it is. And so they're both going to be negatives. The signs are the same, both negatives. Hey, that's a 3 at the back. I know that 7 and 3 each only have one factor. So this one should work out simply. Let's put the 1 and the 3 in the back, and let's try 1a and 7a in the front. The only possibility is that they might switch, and we'll check on that in a sec. So our outer and our inner are negative 3a, negative 7a. That totals negative 10a. Well, that's what we wanted. So let's write our answer. Very simply, a minus 1, 7a minus 3. You'll notice I didn't write the 1 in front of my a because I don't need to. Our next problem, problem 4, has a minus sign at the back end and a positive in the middle. Well, the minus sign at the back end is going to lead us to a plus and a minus. That plus and a minus is because of that negative 8. What two numbers multiply to a negative? Well, I have factors of 5 and factors of 8. Factors of 5 are just 1 and 5, but factors of 8, there's two possibilities. 2, 4, and 1, 8. Well, let's put the ones in that we're sure of. 1x and 5x, because of the 1 and the 5 are there for sure. Once again, I'm always going to try the closest numbers together, so I'm going to try that 2 and 4. I'm indiscriminately putting it in. I don't know if it's right or wrong. It might be 4 and 2, but let's see. We multiply the outsides, we multiply the insides. Outsides is negative 4x. Insides is positive 10x. We add those together and we get 6x. Sure enough, that's the right answer. So our final answer will be x plus 2 times 5x minus 4. Hopefully you're starting to see that there's a little bit of scratch work on the side, but in general, these problems are going to work out fairly quickly. Here we go on to a number problem where we have numbers that are a little bit larger, but I think you're going to find it's okay. Do you notice what's different about this problem versus our previous one? In this case, we have the previous one didn't have many choices for both, but this one has a couple. So, as we look at 6 and 20, let's try to write down the factors. 1 and 6, 2, 3, 1, 20, 2, 10, 4, 5. Well, let's try to puzzle this through. It's a negative 20 right there. That means the signs have to be opposite because of the negative number. Next, let's shoot to say, hey, let's always try the 2, 3 first instead of the 1, 6. If that doesn't work, then we'll go back to the 1, 6. But we're going to start by trying the 2, 3. Here's where it gets fun. We have to consider the idea of a GCF. And so I'm going to put a question mark here with a GCF as a thought. Because we look up to the original problem, we say, is there a GCF between 6, 7, and 20? The answer to that is no, there is not. Because there's a GCF not in the first problem, there can't be a GCF in either final factor. What does that mean? Well, as an implication, if I were to put a 20 in here, then between the 2x and the 20, there would be a GCF of a 2. So I can't put a 20 in there. All right, let's take a look at some other possibilities. Could I put a 2 or a 10 in here? If I put a 2 in there, there would be a GCF between those two. In comparison, if I put a 10 in here, there would be a GCF between those two. So what does that mean? I cannot use 2 and 10 at all. In the same way, if I try to put a 4 in here, a 4 can't be in that one. So we've whittled down a number of possibilities. The only thing left that we possibly can try is 5, 4, or 120? I'm going to go with the 5, 4 because they're closer numbers together. Now let's do our FOIL with the OA part, and let's see if we got it. Outside is negative 8x. Inside is positive 15x. That gives us 7x as a result. That's opposite of what we wanted, so all we're going to need to do is change our signs. So this first one becomes a negative, and the second one is going to become a positive. Let's write our answer neatly below. 2x minus 5 times 3x plus 4. I like that problem because it gives us a chance to knock out different answers whenever we have. Now I've kind of created a humdinger of a problem at the very beginning if we're going to kind of come back to our first page. I want to look at a humdinger that we have that I've made up that would normally look like a very hard problem. 6x squared plus 17x plus 12. I've got factors of 6 and factors of 12. 1, 6, 2, and 3. As we consider these two, then we've got 12 is 1, 12, 2, 6, 3, 4. Those are very doable problems. Can you tell me what the signs are going to be? Hopefully you're thinking it's a plus and a plus because the same signs, we come back here and we notice it's going to both be a plus. Now, I'm going to go with the 2 and the 3 because they're closer together. So 2x and 3x. Now we start our game. We consider, could we put a 1 and a 12 in? Well, if we put a 12 in here, the 2x plus 12 would not work because that has a GCF. If we put the 12 in over here, the 3x and the 12 also have a GCF, so the 1 and the 12 are discounted. If I put a 2 in here from the 2 and the 6, 2x plus 2 has a GCF, and if we put a 6 in here, 2x plus 6 has a GCF. So the 2 and 6 are out. That leaves us with 3 and 4. Can I put a 3 over here? Well, the 3x plus 3 would have a GCF, and that won't work. So by default, the 3 must go here, and the 4 goes here. Now, if this one does not work, then we're left to go back to the 1, 6 as a second possibility. So let's see what we have from inner and outer. That's 8x on the outer. That's 9x on the inner. That gives us 17x as an answer, and that is exactly what we wanted. So my final answer is going to be 2x plus 3 times 3x plus 4. As we're finishing this up, I want to go back and look at our squares at the very end of our problem. You remember our squares we have for 19 squared, that was one of our patterns. 9 times 9 is a 1. And 19 squared is 361. 20 squared is 400. So that's our squares for today as we look at those. Just a reminder, the familiarity between 17, 18, and 19 squared. They each are 3 blanks as their answer, and we look to what they have ending in each one. 7 times 7 is a 9, so 49. 8 times 8 is 64, so that's a 4. 9 times 9 is 81, so that's a 1. Then, our special pattern for this says each of these 7, 8, and 9 times 4 are the other numbers. 7 times 4 is 28, so that's 289. 8 times 4 is 32, so that's 324. And 9 times 4 is 36, so that's 361. Hopefully that's 3 simple tricks that once again remind us what 17, 18, and 19 are as our perfect squares. I hope you've enjoyed the lesson on factoring trinomials.